Hi, and welcome to Lesson 6 of the course Mastering OEE. In this lesson, we'll calculate OEE according to the original Nakajima approach using real numbers. This will lead us nicely to the next lesson, where we will look at the waterfall approach for calculating OEE. After this module, you should have a thorough understanding of what OEE is and a clear idea of what the OEE metric represents. So let's get into it. First, the 6 big losses and OEE. As we know from previous lessons, OEE gives us a numerical value for potential improvement. It takes into consideration the availability, performance, and quality of output for a piece of equipment. Looking at Nakajima's OEE calculation from another angle, you can say it rolls the 6 big losses of total productive maintenance into a percentage that represents the effectiveness of that machine. These 6 big losses are 1. Equipment failure. 2. Setup and adjustment. Then we have speed losses that affect performance. Third is idling and minor stoppages. Fourth, reduced speed and operation. Then we have defect losses that affect quality. Number 5 is process defects, and number 6 and final is reduced yield. Now, let's calculate the OEE for production system by giving these 6 big losses some real values. We'll start by calculating the availability. As you'll recall, the availability rate is the operation time divided by the loading time. For our example, we'll say the day is 8 hours long, which is 480 minutes, and we only have 20 minutes of planned downtime. This leaves us with 460 minutes of loading time. Now we need the downtime to get the actual operation time. We can say that during this day we had 40 minutes of breakdowns and 20 minutes of setup and adjustments. This gives us an actual operation time of 400 minutes. Now we have enough information to calculate our availability rate. Now it's time to look at how efficiently our equipment is being used during production times. For our example, our ideal cycle time, also known as validated speed, is 0.5 minutes per unit. We can say the amount of parts that were actually processed was 400 units over 400 minutes of operation time. You probably already see that our equipment has been underperforming compared to the ideal cycle time. But by how much? By inputting the values into the equation, we have 400 units times 0.5 divided by 400 minutes. And this gives us a performance efficiency of 50%. We now know our availability rate and performance efficiency. But what was the right first-time quality of the units we produced? Fortunately, quality is very easy to calculate. Let's say we produced 400 parts, but 8 of them were defective. Maybe they became scrap or rework. It doesn't really matter. Our right first time count was 392 units out of 400 units, which gives us a quality rate of 98%. Depending on which industry you're in, you could see 98% as a good quality rate or disastrous. Now it's time for us to bring the availability, performance, and quality rates together to calculate our OEE. Our earlier calculations gave us the following scores. Availability rate equals 87%. Performance efficiency equals 50%. And finally, quality rate equals 98%. Multiplying these together tells us that our overall equipment effectiveness was 42.6%. And that's it. We now have OEE according to Nakajima. Next up, we'll look at FactBird's more modern waterfall method for calculating OEE. Thanks for watching, and see you in the next lesson.